Hi everyone, I'm creating this tutorial to support you for training. Basically, we're gonna make a tutorial for Module 2. I'll show step by step how you can calculate and how you can define the device you're gonna use in your project. Here, I'm sharing with you the test project Module 2. Uh, you can read the content later, the description of the task, but the purpose here is showing what we're gonna do. First, here we have the instructions. The first instruction is saying for through the Google Earth, you find this place through these coordinates. So basically, we're going to copy, open the Google Earth, and paste the coordinates and check. And automatically the coordinate will appear to you. If you take a look in the task, we already have the area of the building we are looking for. It means that our solar system must be installed inside this area. The other step we're gonna have is the delimitation of the boundaries of the land and the rules. Because through this delimitation, we're going to know where we can install our system. Going back here, so it means that we're talking about this area here. And I will look for, inside this area, a place to put the solar panels. Remember, solar panels, they must be in contact of the sunlight. It means that the solar panel, they will be installed on the roof. Can be installed on the ground also, but it depends on the place. If there's no shadow, if there's no obstacles around. In this case, we're going to find a roof place. So when we look here, here is the Adipoli ATS and Activate building. We have to look for a place to install our solar system. For example, in the middle here, I will just use a line to show you. In the middle here, I can't install the solar panels in this area. Why? Because if you take a look, it's a kind of glass. We cannot install it here. You can install, but you need extra material, extra structure. This is not the wisest decision to take. We have other places here. For example, we have this roof here with some glasses in the middle, same like here, same like here. We have a small piece of roof here. Take care because we have some obstacles here of the AC system. We have a big roof here. We have a big roof here with 3 parts of glass. And here we have another big roof. Here we have another one, but we have many obstacles. For example, we can choose this place, or this place. Once you choose, you have now to check if your solar system will fit. How can I know if my solar system will fit? First, I have to calculate and define how many solar panels I will use in my system. Coming back here in our description, we have the consumption of the building. So we have to calculate. So I will use the same Excel sheet we used in the skill challenge to calculate. So we're gonna put the consumption here, the amount is 0.293 US dollars per kilowatt. And this is the consumption. In the end, we're going to calculate and find the average consumption in a year. The second step, we're going to define the irradiation. See here that the steps we took until now are very similar we did in skill challenge. Only the values has changed. The irradiation, so we're gonna go to the irradiation map that is available for you here in the official documents, test project, module 2, global irradiation. Here in the map, you see that Adipoli is located in Mohammed bin Zayed City, exactly in this area here. If you come here in the scale, we can see that the radiation will be around 5.9 to 6. If you choose 5.9 is okay, if you choose 6 is okay. Then I'll go back and I'll put our radiation 5.9. Next step, we have to define the power of the solar panels. Where you go to the datasheet, solar panels, and you choose one of these three. Let's choose, for example, the third one in this case. So the third one is this model. Here's the trick. You have to define by yourself the power of the solar panel you're gonna use. Later on, I'll explain you why it's very important for you define it in the beginning. However, you may change it in the end. You might change it in the end. Because one information that is very important is the dimensions, the size of our solar panel. Because we're talking about a real project, we're going to define a real area, and I cannot exceed this area. Otherwise, it's impossible physically to install our solar panel. The calculation will work, but physically I can't install. This is not right. This is not professional. This is not the standard we're looking for. So coming back here, let's say, for example, we're gonna use, let's say, a 550 watts. So I come here, 550 watts. It means that we're gonna use around 149 solar panels, considering this power of the solar panel we are using. Why 149? Because it's impossible to have a slice of a solar panel. And as the value is more than 148, we're going to use 149 solar panels. Good. Knowing that, I'll go back here in the solar panel datasheet. If you go down, here is the datasheet of 550 watts. And we can see here in dimensions that the solar panel has around 2.3 meters per 1.2 around. Why is important to know that? Because now we're going to check if the place will fit properly the solar panel as we're expecting. Let's say, for example, here. How can I know if the place will fit? If you check in the test project, I requested you to include the images, the prints of the relevant information. And when I ask you for the first part, site parameters, I ask you the screenshot of the coordinates, and I ask you the screenshot of the area plus perimeter. How can I define it? I come here to the Google Earth, make sure that you click here, and we're gonna add a path. Here to here, here to here, here to here, here to here. Let me just see if I can change to English because mine is in Portuguese. I don't think so I can. Anyway, let's keep like this. Okay, I'll keep it in Portuguese. You can find in English is the same way I'll do. So here we can see that the perimeter of the area I was looking for is 139.4 and the area is 1190.81 meters square. We can keep it like this, and it's very important for you make a print screen of it. Why? Because I asked you to show the area, one of the pictures we're looking for. Let's open here the paint. Uh, let's cut this information. Crop. I'll save image one. Okay, this is the first step. The second step was requested to you the PV local coordinates, the exactly point we're going to put it. We're going to install it. So you click here to add a marker like this. You drop it here. The title you're going to use M2 means module 2. Your name, for example, William Lopez. And your boo, for example, my workstation is the workstation number 5. So I will put it W5, workstation 5. This is the title of my project. And here are the coordinates we're looking for. It's done. So in the test project, the first thing that you have to fill here is the coordinates. So come to here, click here, it already copied to the transfer area. Click here and paste it. That's it. This is the coordinate we're going to install our solar panel. This is the place we're going to install it. If it's a little bit right, little bit left, doesn't matter, because I requested you to add the print screen of it. So make the print screen again, open the paint again, paste, cut it again, drop. That's it. And save it as image number 2. That's it. So now we have the coordinates we found. We also have the delimitation area. I'll do it again. So check the borders of the roof. Here and here. So this is the area we have available. Save it. Here you can change the length of the line. You can use bigger lines, you can use a little bit smaller, and the opacity of it. In the test project, I will ask you one specific configuration that you have to do. For example, like change the color to blue, keep the length like 8, and the opacity like 50%, like this. That's it. Once you have it, you have here the area and perimeter. I'll do the print screen again because I missed the first, I didn't save it. 8, 2, I will crop. That's it, and I'll save as image 1. That's it. So now I have the print screen with the perimeter and the area. and I have the print screen of the coordinates. Here in the Google Earth, our job is done. Now I'll go to the project. The area is 137.6. 137.6. This is the perimeter, sorry. The perimeter here, 137.6. And the area, 1,160.93 meters square. Insert a screenshot here of the coordinates in the Google Earth. So you can delete it. Come to insert pictures. I think mine are in the desktop. The coordinates are in the image number 2. Insert pictures number 2. That's it. So here I have the coordinates of the place I will install the solar panels. And down here, the print screen of the area and perimeter. That's it. The first part, it's okay. The coordinates on where I will install my solar panels, the total area, and the total perimeter. Why it's important to know the area and perimeter? Again, as we're talking about a real project, we have to pay attention in the area available. Because sometimes if I need too many solar panels, I will not have enough area and I have to define another place. I have to split it in 2, 3 different places. It will depend on the device you choose. I mean, solar panels. Going to the next stage, we're looking for the solar panels itself. So through the calculation, again, I'm using the Excel sheet. You expert, you can use the Excel sheet to make your life easier to check if your competitor is doing it properly, it's right, if it's right. However, your competitor in the competition, you do it in a sheet of paper with calculator, with a pencil, eraser, and that's it. You have to do it manually. You not have access to this Excel sheet here. Through our calculation, was defined that we're going to use 149 solar panels. So what I'll do now, I'll choose in our datasheet solar panels. Actually, we already did it. We choose the 550, this model here. And we have now to fill in this information. First, the manufacturer code. The manufacturer code is for this model is this one here. Mono half cell, 10 BB, and the power of the solar panel. So we need mono half cell. Mono half cell. 10 BB. 550 watts. This is the manufacturer code of this model. In the competition, this model will not be available to you. It's just a tutorial to show you step by step. In the competition, you have 2, 3, maybe 4 different datasheets and you have to choose by yourself. The power is 550. The voltage we're looking for here. Remember, we're looking for this place here. The voltage we're looking for is the P max in the standard test conditions. Okay, don't use this other one because this other one is a test that considers the radiance around 800 watts per meter square. We're looking for the standard test conditions now. The voltage, the maximum voltage we're going to use is 41.57 volts. The maximum current we're gonna use is 13.23. The size of the solar panel will be available somewhere here. You can take it from here or here. Production dimensions. So here are the production dimensions. And the weight is available also here in the datasheet, 28.5. 28.5. So these are the data of the solar panel I choose. Remember, you choose it. You define which solar panel we're gonna use. Here, we're gonna insert the datasheet solar panel highlighted. So delete it. Come to the datasheet. This is the first page. Okay, I'll make a paint screen. I'll put it here. I will group just the page like this. I will save it as photovoltaic panel datasheet 1. I'll go to the second page. I'll do the same thing, print screen. Group, save, datasheet 2. Okay, save. That's it. Then I'll go back here. Insert pictures, datasheet, page 1. You can adjust as you wish the size here, like this. You can move it right, copy and paste. Here. Make sure that it's aligned. Here, I'll insert the picture number 2. That's it. So we have here, until now, the coordinates, the total area I'll install my solar system, the perimeter, the print of the coordinates, the print of the area, the delimited area. And here for the solar panel, the manufacturing code, the power, maximum voltage per solar panel, maximum kilowatt per solar panel, the size of each solar panel, and the weight of the solar panel. And here the datasheet itself. The second step for the solar panel is okay. Now we have just to make a verification if this solar panel fits in our place. How can I do it? Use this measuring tape to check the length from here to here. So 28 meters. 28 meters here, and let's say 37. 28 per 37. It's important to check the perimeter, the sides of the place, because now we're gonna check if check how many solar panels we can install in array. For example, if each solar panel has two, let's check here. Down here, yes, has 2.2 meters. when you check here, let's say that we have 2.2 and we have 28. So we'll open here the calculator. We have 28 meters, 2.2. Yes, we can have 12 solar panels here, one after the other. We cannot have more than 12. In the end, in our calculation, we defined 149 solar panels. If in a row I can have only 12, it means that I'll have 149 over 12. It means that we're going to have 13 arrays of solar panel here, of 12 each. So we already know the perimeter and we know the sides of our place. I will use the AutoCAD just to show you what I'm talking about. Imagine that we have a rectangle with 28, sorry, 37 per 28. This is the area of the roof we have available. This is the area of the roof. One solar panel, when you come here and check the side, it has this dimension. 220,000, right? So it has, let's say, 2079 per 1134. So this is one solar panel. We have to have here, according to our calculation, 149. So 149. Okay. 149 solar panels with this dimension here. Coming back here to our Google Earth. So this is our roof and this is our solar panel. We have to have 149. So we have here one arrangement of 149, and it means that it fit in the roof. Doing by calculation, you just have to know the length of the sides, the size of the solar panel, and check if they fit inside. If they fit inside, it's okay. Knowing that, I can see now that the place is good. All the solar panels I need to install, they will fit inside by the calculation. It means that the solar panel I choose is okay. Okay, coming back here. It means that the solar panel is good. I can use it. This one is proper. The size fit the amount I need, 149, the power, and etc. Now let's go for our inverter. The inverter parameters. First, we have to define the number of inverters. If we're going to use 1, 2, it will depend on the model you choose. Let's say, for example, that I'll choose the first one here. This one. This inverter is one 3-phase string, and it's 80 kilowatts. How can I know the power? Well, through the calculation. If we check our calculation here, you see that the minimum is 65 and the maximum is 97. So this one, 80, works well for us. It's between the maximum and minimum. we could use any inverter between 65 and 97. Any of them would fit here. Okay, let's consider we're going to use this inverter. We already have here the model name. And we have to check now other parameters. For example, the maximum voltage per MPPT. You have here information, the number of DC inputs. We have 18 inputs, 2 inputs per MPPT. It means that we have 9 MPPT. This is one important information we have to check. The voltage, it's 100 to 1000, the minimum and maximum. And the current, total 234, maximum 26 per MPPT. Why it's important? Because now we have to make a cross check with our solar panel and check if this inverter is good or not. It will work or not with our solar panel. Okay, we have 149. We have 149 solar panels. It means that we have to connect them in series. We have to define the arrangement of them. Let's say, for example, we're going to have 15 rows of solar panels with 10 solar panels each. It means that we're going to have 150 solar panels. For our calculation here and verification and cross-check, if we can use this solar panel, what we can do? If I'm going to have 15 arrays of 10 solar panels, I have to check the voltage. How to check the voltage? If the voltage is enough and it's safe to connect the solar system, I can have in the maximum 26 amperes per MPPT. We have 9 MPPT connections with 2 inputs. It means that we can connect until 18 arrays. Now we're going to cross-check with the data of our inverter. I'll open the calculator here. I'll keep the calculator here because this data in the middle are not important. So I will have, in this example, you can choose many different ways of doing this. But in this example, we'll have 10 solar panels in one array. It means that I'll connect them in series, so the total voltage of them is times 41.57. It means that the total voltage per array will be 415.7 volts. I have to check if this fits inside the voltage in our MPPT. Here is saying that the inverter works from 180 to 1000. It means that this voltage is inside. It works. We can use it based on the voltage. Another thing that we have to check is the current here. For current, we're going to do the same. As the strings, as the arrays will be connected, or as the arrays will be connected in series, it means that will be the same current for all devices. And here in the datasheet for the 550-volt solar panel, is saying that the maximum current of the solar panel is 13.23 amperes. It means that we can connect 2 arrays in the PPT and the current will not exceed in the maximum 26 ampere. It would exceed 0.4, but in this case, we can use this device here. So we have 18 inputs we're gonna have 15 arrays, so it's good. We have 26 maximum, and the array will work with 13. We'll have the maximum voltage 1000, we're gonna work with 415. It means that this inverter fits this solar panel system we're gonna create. Now the last stage, we just have to copy and paste the data from inverter, the name. We're gonna use just one inverter because the power of this inverter is enough for the system we're gonna have. The kind of inverter we'll choose, as we're talking about an entire building, is better to choose a three-phase device. Because a three-phase device, you can connect three-phase machines. We don't know what the customer will connect. So based on that, consider three-phase. The power is 80 kilowatts. The voltage range is from 180 to 1000. The current is 20 is 300 234. And the size will be here somewhere. It's here, the size. The weight, 82 kilos. 82 kilos. Now, the data sheet, as we did for the solar panel, we're gonna do here same. Open it. Print screen. Paint. Group it. Group. Save as inverter. Inverter datasheet 1. Let's do the same for the other page. Print screen. Datasheet 2. Perfect. So I will insert it. The page 1 here. Yes. Now make adjustments here. Arrange it as you wish. Make sure that's aligned. Delete the image. Add the second one. And that's it. All the datasheet we used, the parameters of the inverter, and last, the project parameters. The number of solar panel we defined was 149 through the calculation. The total power capacity is the total capacity we calculated here was 81. .41 kilowatts around. The money saved. The calculation of the money saved, it's easy. You have here the power, you have here the price per kilowatt. The consumption, the price per consumption, just multiply them and you get the value in the end. So let's see, 1230 plus 10, 620 plus 1202 plus 10, 40 plus 12520 plus 10, 920. 1220 plus 10,720 plus 12,620 plus 12, plus times 0.293. So using the solar system based on the consumption of this installation, we're going to save approximately 4,000 dirhams per year. And that's it. You finish the calculations. For you competitors, you receive this calculation page. So you do your calculation here. I did through the Excel sheet just to simplificate and make the video a little bit shorter. That's it. If you have any question, please share with me in our meeting. Thank you.